acid. Now let's move towards the pantothenic acid. There is nothing much more about the pantothenic acid. It's just a quick review regarding the pantothenic acid. So what you have to remember regarding the pantothenic acid, we have got riboflavin, FAD, FMN, coenzymes. Again, what we get here in pantothenic acid, we're going to get a coenzyme. Remember, in the B1, B2, B3, there is no B4. We're continually coming. I have searched for the B4, but there was no enzyme. There was no vitamin named as B4. So you're going to jump up from B4 to B5. That is a pantothenic acid. And again, we are going to get a coenzyme. Exactly. So the pantothenic acid provides coenzyme A, which actually helps in transfer of acyl groups. All right. Pantothenic acid, we're going to get a coenzyme, which is called coenzyme A, which actually helps in the transfer of acyl groups. That's it regarding the pantothenic acid. So one thing more to add up in the pantothenic acid, which is it is also a component of fatty acid synthetase. Remember this one. This is an extra point. You have to remember it. So whenever somebody says which vitamin is the component of the fatty acid synthetase, you're going to directly answer them with that is the pantothenic acid. That's it. All right. Just very easy, quick review regarding the pantothenic acid. I'm just lengthening the lecture in order to remember you, but make sure it's very easy. It's not that much difficult. So number 6, we have got, or you can see vitamin B6. We have got pyridoxine. So all right, the pyridoxine, and very interesting vitamin. Not that much, but it's kind of interesting. So the pyridoxine actually, you can say it's a B6 vitamin. So it have got different, the forms that have got pyridoxal, pyridoxamine, or you can say, but the biological active or the coenzyme is actually the coenzyme pyridoxal phosphate. Similar, we have got coenzyme here, coenzyme here, coenzyme here, coenzyme here. In the B1, we are going to get all coenzyme. In the coenzyme pyridoxine phosphates, which actually, this is actually going to help us in the protein catabolism. Remember, in the protein catabolism, if they're asking you which vitamin, actually major vitamin going to help you in the protein catabolism, you're going to answer them that it's the pyridoxine, or you can say the biological active form, that is the coenzyme pyridoxal phosphate. All right, I've mentioned here TB. I didn't mean anything that causes TB or something else, but there was a related thing I have to explain regarding this vitamin. So what happens? There is a drug. It is named as isoniazid, which is also short form as INH. This is a drug. When this drug is actually prescribed to patients having tuberculosis. So when you are giving a person this drug INH or to treat TB, so what you have to do, you also have to give that patient vitamin B6 or pyridoxine, because the isoniazid or an INH, a drug used in the treatment of tuberculosis, can cause vitamin B6 deficiency. Remember this thing. If you're going to give this one, this is going to cause the deficiency of vitamin B6. So you have to give an extra supplement to the patient in order to meet up the vitamin B6 requirement. All right. So this is all about vitamin B6. Now let's move towards the biotin, which is the vitamin B7. Vitamin B7 seems a little bit, known, the word biotin. Most of the time we hear it. So what you have to remember, in similar sequence, we have got a coenzyme. So in this case, there is a special thing. So the biotin is actually a coenzyme of carboxylase. It is not going to give a coenzyme or the active form. This is itself is a coenzyme of carboxylase. So carboxylase is an enzyme which is a coenzyme that is biotin. So biotin is actually a coenzyme of carboxylase. So it actually helps in the carboxylase, or you can say in adding carbon dioxide in certain chemical reactions. Now let us move towards the folic acid or tetrahydrofolate. That's a deep lecture that need another lecture, but I'm going to make it short and easy in order to make you remember to make it easy for you to remember this folic acid. So what is folic acid? So folic acid is vitamin B9, which is not an active form. The active form of vitamin B9 is tetrahydrofolate. So when folic acid goes through two-step reaction, it's going to convert into the tetrahydrofolate. So the conversion of folic acid into tetrahydrofolate, we need two important things. That is the vitamin B12 and vitamin C, which is also called as the ascorbic acid. So remember, tetrahydrofolate is not going to be formed from folic acid directly because we have discussed it here. So we need ascorbic acid and cyanocobalamin to help this guy to form the tetrahydrofolate, because this is going to play an important role. Because if it is deficiency, we're going to get megaloblastic anemia. So folic acid also helps in the one carbon metabolism. So what is one carbon metabolism? All right, wait. One carbon metabolism, I have to make a real different, extra lecture for explaining the one carbon metabolism in detail. So at this point, we're just going to avoid it. You have to remember it, that one carbon metabolism is actually, folic acid actually also causes the one carbon metabolism. And I have described here purines and pyrimidines. So what does that mean? So that means that means that tetrahydrofolate is essential for biosynthesis of purines and pyrimidines bases. Especially, there's one thing I haven't wrote, that especially thiamine. You have to remember this, especially thiamine. All right, I'm just not going cross line, just fast. All right, especially thiamine is going to, that's why I made this lecture is easy, because I don't want to mess up the board, because I'm too fast in writing and I just don't know what I write. I just write it fast. All right, where I was, purine and pyrimidines. All right, I have made it clear. This tetrahydrofolate actually helps in the formation of purine and pyrimidine, which is actually helps in the which are actually the nitrogenous bases, which are essential for DNA synthesis. That's why you're not going to mess up with the DNA. If you're going to mess up with the DNA, the megaloblastic anemia is going to form. So I'm going to make it quick, all right? How the megaloblastic anemia is going to form? If you have deficiency of tetrahydrofolate, even we have got folic acid, if you don't care, if you don't got cyanocobalamin, if you don't got ascorbic acid, tetrahydrofolate is not formed, and we need tetrahydrofolate at any cost. So what is that? If this guy is not present, we are going to get megaloblastic anemia. So what happens in megaloblastic anemia? The RBC, the purines and pyrimidines are not going to form. So there is a problem with the DNA, with the replication. So DNA is not going to be mature. So the RBC cells which are present in your bone marrow are not going to be mature. So your body needs blood. So if the immature, because the tetrahydrofolate helps in the maturation of RBCs. If those RBCs are immature, because the tetrahydrofolate is not present, but blood needs, so the circulatory system needs blood anyhow. So these cells immaturely get into the circulatory system and those cells are immature RBC cells. So they cause the megaloblastic anemia, because megaloblast is in the stage of the formation of the blood. So that's why we call it the megaloblastic anemia. This was a brief lecture combining the folic acid, cyanocobalamin, and ascorbic acid, which are actually important in converting the folic acid to the tetrahydrofolate. So that's it about the folic acid. Now let's move toward the cyanocobalamin.